Hello, welcome to Microsoft Azure training series powered by ATCSL. My name is Neeraj. I am an enterprise architect, Microsoft certified Azure Administrator Associate, and I will be your instructor for this course. So, what are we going to learn today? Today, we are going to have an overview of Azure Virtual Networks. Now, this is a part 1 of the Azure Virtual Network series, which in turn is a part of the AZ-100 examination for the Azure Administrator Associate, and under the section Configure and Manage Virtual Networks. And in this session, we are going to understand and have an overview of the most frequently used terms which are part of the life of an Azure Administrator, and he has to deal with this on a daily basis. And these are subnets, network security groups, network interfaces, IP addresses, VPN gateways, load balancers, application gateways, and traffic manager. I know many of you must already be aware of these terms, and in that case, you are more than welcome to skip to my next video, which dives deep into more details and has hands-on session as well. So what are we waiting for? Let's get started. What is a virtual network? A virtual network in Azure is exactly similar to the network that we have in our on-premises environment, helping us connect different resources. Azure Network helps us connect virtual machines, create a connected system as a part of the farm so that they can communicate with each other, and talk to the on-premises systems as well in a special connected scenarios, like we have point-to-site VPN or site-to-site VPN or express route. So those are the things that we are going to cover in the later sessions. But as of now, this is just an overview, so we are going to leave them. Now, each Azure subscription can have multiple Azure regions, and each Azure region can have more than one virtual network. Virtual networks, therefore, are isolated from other virtual networks even when they are in the same region. Now, these virtual networks, they have their own private address space as defined during their creation. So when you are creating a virtual network, you need to define an address space which is specifically allocated to that particular virtual network. And they can have one or more subnets with their own address space allocated. So when we are creating an Azure virtual network, and we define the CIDR address space, and within that address space, we create a subsection of it and allocate a part of it to a different subnet. And these subnets provide separation of concerns. So these address spaces, they're the part of the main address space of the actual vNet or the virtual network that we have created. With the provision of the virtual network, Azure provides its own name resolution using the Azure DNS. There is additionally an option to configure your own DNS server if you own a domain name, if you already have a domain that you have registered through a registrar like Kentoso.com. So if I go to GoDaddy.com and have my own domain name, I can configure my vNet to use that particular domain name. And again, this is a part of the later sections, the things to be covered later in the later videos, but not for now. The resources thus created can use the configured domain name. Okay. Moving next, let's understand what subnets are. Now, as I already told you, subnets provide separation of concern within the virtual network. And the resources within the virtual networks can be grouped together into different subnets depending on the requirements. If you refer to the image on the right-hand side, we have two different subnets, which are front-end subnet and the back-end subnet, and they are the part of the main virtual network. And if you see, all the virtual machines which play the part of the web front end, they are grouped together into the front end subnet, whereas all the servers which play the part of the data tier as a database, they are grouped together into the backend subnet. And each one of them, they are controlled by the NSGs, which define the rules to move the traffic between the different subnets. Some of the resources, they require their own dedicated subnets, like an application gateway, that we are going to discuss later. But for now, if you want your on-premises resources to talk to the Azure resources, you need to have an application gateway in place. Coming back, each subnet must have a unique address range specified in the CIDR format within the address space of the virtual network, which can not overlap with the other subnets in the same virtual network. Azure routes traffic between all the subnets in the virtual network by default. So all the resources by default can communicate with each other, but again, they depend on the rules that are defined in the network security groups if that is attached to the subnet. So there is a possibility for you to associate network security group to each subnet, and therefore all the VMs within the same subnet will follow the rules defined by the network security group associated with the subnet. You can associate the same or different network security group to each subnet. Now comes the network security group, abbreviated as NSG. And NSG is a part of the virtual network which has a set of rules defined for managing the inbound and the outbound traffic to and from the virtual machines. The NSGs can be assigned to either the NICs, which are the network interface cards, or to the subnets. If the NSG is assigned to an NIC, only a single VM to which the NIC is allocated gets affected. On the other hand, if the NSG is assigned to a subnet, all the VMs within the subnet will follow the same rule. Every rule defined in the NSG has a priority assigned. There are some default or predefined rules set which cannot be deleted, but their rules have the highest priority set. That is, they have the lowest priority and can be overridden. So if you look at the image, we have the inbound security rules and we also have the outbound security rules. And we have 3 predefined rules which are set already. So these rules, if you see, are 65,000 and more. So they have, although their priority has the highest number, but the more the number, the lowest is the priority. And if we want to override any of these, we need to define a rule which overrides them and which has the lowest priority number, but that means it will have the highest priority and will be followed. I'm sure all of you are aware of what a network interface card is. It's a piece of the hardware device which is there within your laptop or a desktop and enables you to communicate with other resources within the network. In a similar way, we have the network interfaces for the Azure Virtual Machine as well. It allows the connectivity between Azure Virtual Machine and the vNet, enabling the VM to communicate with internal and external resources over the network. One virtual machine can have more than one network interface depending upon the size of the VM opted for. So when you are creating a new virtual machine, there is an option for you to select the size of the virtual machine, and that will all depend on the pricing and your own requirement and what you need. But different sizes will have the option for you to create or to have one or more network interfaces. We all know about the IP addresses, isn't it? But just as a revision, IP addresses are assigned to resources to communicate with each other within and outside of the Azure. We can also connect to our on-premises network as well as the internet. There are two types of IP addresses in Azure. One is the public IP address and one is the private IP address. For the public IP address, these IP addresses are used for communications over the internet and also with the public-facing Azure services. The public IP addresses can be assigned to the virtual machines, to the external or internet-facing load balancers, which are layer 4 load balancing, VPN gateways, which are configured for the point-to-site and site-to-site connectivity, and the application gateways, which are the layer 7 load balancing feature. The Azure public IP addresses is created with either the basic SKU or with the standard SKU. For the basic SKU, they can be assigned with either the static or the dynamic allocation method. Network security groups are recommended but optional for restricting the inbound or the outbound traffic. IP addresses under basic SKU are not zone redundant. When we talk about the standard SKU, they can be assigned only with the static allocation method. When using the standard SKU, we must explicitly whitelist the inbound traffic, which needs to be allowed by configuring the IP addresses, ports, protocols, etc. This SKU is zone redundant. Now coming to the private IP addresses. The private IP addresses, on the other hand, are used for communication within an Azure vNet. These IP addresses also allow communication with your on-premises network when a VPN gateway or an express route is established with the on-premises network. So that is using the site-to-site or the point-to-site connectivity. The private IP addresses, they can be assigned to the virtual networks, to the internal load balancers, and the application gateways. We have been discussing and talking about VPN gateways in our previous sections. What are VPN gateways? The VPN gateway will help connecting networks such as Azure Virtual Network with another Azure Virtual Network, or the Azure Virtual Network to the on-premises network resources, such that your on-premises network resources can connect with and talk to the Azure Virtual Network resources. One thing that should be kept in mind particularly is that whenever you are creating a VPN gateway, they are always created in a separate dedicated subnet, and they cannot be clubbed together with other resources within the existing subnets. So when you create a VPN gateway, it has to be a completely different subnet with the IP address range, which does not overlap with any of the addresses that have been previously consumed by other subnets. As per the Microsoft documentation, only dynamic basic SKU IP address can be assigned to the VPN gateway. We will also see a demo on creating a point-to-site or site-to-site connectivity using the VPN gateways in the hands-on module of the training series. But for this particular training, this is all theoretical. Next is Azure Load Balancers. Now, Azure Load Balancer are layer 4 load balancer operating at TCP and UDP levels, and they deliver high availability and performance for your applications. Now, there are other load balancing techniques available as well, like the application gateway, which we have discussed a bit in the previous sections. But those application gateways, they operate at layer 7 and are a bit different. They only handle the HTTP and HTTPS requests. Whereas the Azure Load Balancer, operating at layer 4, they work on all types of requests coming in. So they load balance incoming traffic to your VMs, and they also load balance traffic across the VMs inside the virtual network. To make it more clear, or to simplify this, we can say that there are two kinds of load balancer. One is the external load balancer and the other one is the internal load balancers. The external load balancers, they manage the incoming traffic from the public internet, whereas the internal load balancers, they manage the traffic coming in from the virtual machines and going to the other machines within the same virtual network or the different virtual network. But they are internal, they are private to the virtual network, they're private to the your subscription within your resource group. They also help in forwarding the traffic to a specific port on a particular VM with the defined inbound network address translation rules, which are called NAT rules. And they also provide the outbound connectivity to the VMs in the vNet using the public load balancer, which we have already discussed, that there are two kinds of load balancers, the external as well as the internal. Now we know that with the load balancer, we can create LB rules to distribute the incoming traffic at the front end to the backend pool instances. For this, the load balancer uses a 5-tuple hash-based algorithm for it. What exactly is a 5-tuple hash? The 5-tuple hash is composed of 5 different things, as the name suggests. And they are the source IP address, the source port, the destination IP address, the destination port, and the protocol being used. And then it maps the flows to the available servers. Now, how is the availability determined by the load balancers? This is done using the health probes. What Azure Load Balancer does is independently it will check for the health of the existing endpoints attached to it. So if the endpoint indicates that it is healthy, the requests coming in are transferred to that particular healthy endpoint. But in turn, if the health probe indicates that the endpoint is unhealthy or is not healthy, then it is kept out of question and the traffic coming in is not transferred to that particular endpoint. Rather, other endpoints are used for that particular amount of time for which it indicates that it is unhealthy. After some time, if it indicates that it is healthy again, the requests are transferred to that endpoint as well. So, a server is available to receive new flows when the health probe indicates that a healthy backend endpoint is present. Next is the application gateway. Application gateways are layer 7 load balancers. For application gateways as well, only dynamic based IP address is required. The traditional load balancer operates at the transport layer, which is the layer 4, which is for the TCP and the UDP, whereas the application gateway is more specific and routes traffic based on the URL. They only deal in the HTTP and HTTPS request. They are always within the virtual network. That is, whenever you are defining or creating an application gateway, they have to be created in a separate subnet within the virtual network. They offer SSL termination. Now, what is SSL termination? When you offload the certificate, SSL certificate at the application gateway level, at that time, the encryption and decryption of the request happens at the application gateway level, and the burden or the overhead of this encryption and decryption does not happen at the VM level, so that the optimal performance can be achieved by the VM. The second is connection draining helps you achieve graceful removal of the backend pool members if need be. So once enabled, the application gateway ensures that all the deregistering instances of the backend pool do not receive any new request, and only the existing request, allowing the existing request to complete within the configured time limit. Then we can create the custom error pages also in the application gateway instead of displaying the default error pages. You can use your own branding and layout using the custom error page. You can show your logo or any other text messages if you want. URL path-based routing allows you to route traffic to the backend server pool based on the URL paths of the request. So if you have the request for the images and the URL contains the images, that can be routed to particular servers. Whereas if it contains the videos in the URL, they can be routed to the path to the VMs where we have the videos stored. Now, multiple site hosting enables you to configure more than one website using the same application gateway instance. This feature allows you to configure a more efficient topology for your deployments. We also get a cookie-based session affinity feature with Application Gateway. Now, this is useful when you want to keep a user session on the same server. By using gateway managed cookies, the application gateway can direct subsequent traffic from a user session to the same server for processing. And mind you, this is not the case with the load balancers. Next is the WebSocket and the HTTP protocols enable full duplex communication between a server and the client over a long-running TCP connection. This allows for a more interactive communication between the web server and the client, which can be bidirectional without the need for polling as required in the HTTP-based implementations. There are two SKUs for the application gateway, which we can use for the configuration of the application gateways, and they are the standard and the web application firewall. For the standard, they provide all the features of the layer 7 load balancers, whereas for the web application firewall, abbreviated as WAF, they provide a centralized protection for the web applications to save from common attacks and vulnerabilities, in addition to everything that is under the standard SKU. Let us see the differences between the application gateway and the load balancers. And this is what I promised sometimes back. So to start with, the application gateway, we already know that they operate at layer 7, whereas the load balancers, they operate at layer 4 TCP and UDP levels. The application gateway can distribute only HTTP and HTTPS traffic, whereas the load balancers, they can distribute different types of traffic. The application gateways, they are defined inside the virtual network. And one thing in particular that is to be kept in mind is that they need a different subnet within the virtual network. Whereas for the load balancers, they can be defined inside or outside of the virtual network. Going next, the application gateways have both front-end IP configuration and back-end pools, whereas the load balancers have the front-end IP configuration only. One very interesting thing is that for the application gateway, we have the HTTPS settings to define the cookie-based session affinity, whereas there is no such setting for the load balancer. Now, what is this cookie-based session affinity? Take that you have a web application where you want the request from a particular user A should only be received by server A because his or her previous requests were mapped to server A, so that the session and the data within the session is maintained and the transaction, what is required, is completed. If this does not happen, imagine that the requests from the user A are being directed to different servers where the session is lost and the data is also lost. That will not be good, right? So that is the reason where application gateway comes to picture, They are helpful in those cases where we need the cookie-based session affinity. Now, in addition to these differences that we just discussed, Application Gateway now has a public preview of the new SKU, Standard V2, which was not there earlier. And this offers auto-scaling, zone redundancy, and the static virtual IP. One more thing, that they offer faster deployment and update time, and they're 5 times better SSL offload performance. So both Application Gateway and Load Balancer, they offer the SSL offloading so that majority of the encryption and decryption happens at the gateway level or the load balance level, and the server does not have to compromise on the performance doing such things. Traffic Manager is another point of interest. These traffic managers are the DNS-based load balancers, which enables the distribution of traffic optimally to the services across different Azure regions. Mind you, I said different Azure regions, and they also provide high availability and performance. So by now, we know about the three different techniques for load balancing, starting from the Azure load balancers, then we have the application gateways, and now is the traffic manager, which is the DNS-based load balancer, as I already told you. How does this provide an optimal performance? Consider that your application is hosted in different regions across the globe. So any user requesting for that particular URL or requesting for an application, it is serviced through the nearest endpoint. Traffic Manager helps in directing the traffic to the nearest service endpoint using the DNS based on a traffic routing method and the health of the endpoints. So again, there is a health probe which is involved here. Okay, they increase the application availability, they improve the application performance, they perform the service maintenance without the downtime. That is, you can perform planned maintenance operations on your applications without any downtime. And how it is done? The traffic manager directs the traffic to an alternative endpoint while the maintenance in one of the regions is in progress. We can combine hybrid applications. So the traffic manager supports external non-Azure endpoints, enabling it to be used in a hybrid scenario with the hybrid cloud and on-premises deployments. Okay. One more thing, that it distributes the traffic for the complex deployments. So using the nested traffic manager profiles, which we will dig deep in different session, but for now, so this technique, this nested traffic manager profiles, using this, the traffic manager, it uses the traffic routing methods and can combine to create a sophisticated and flexible rule. And using this, they can scale to a more availability. We know that the traffic manager operates on a traffic routing methods which are available. Let us discuss on what traffic routing methods are available for us. The first one is the priority, which is selected when we want to use primary service endpoints for all the traffic and provide backups in case of the primary or the backup endpoints are not available. We then have the weighted, which is selected when we want to distribute the traffic across a set of endpoints depending upon the weight which we have defined. The third one we have is the performance-based traffic routing method, which is when we have the endpoints in different geographic locations and we want the user to use the closest endpoint and experience the lowest network latency and a high performance. The fourth one is the geographic routing method, which is selected when the users are to be directed to specific endpoints based on their geographic locations and from where the DNS query originates from. We also have a multi-value, which is selected for the traffic manager profiles that can only have the IPv4 and the IPv6 addresses as endpoints. It's not a name, rather it is the IP addresses. The final and the last one is the subnet-based traffic routing method. And we select the subnet traffic routing method to map the set of end-user IP addresses to a specific endpoint within a traffic manager profile. And those are the 6 traffic routing methods which are available in the traffic manager. I know this has been a little overwhelming today because this was more of a theoretical session. But in summary, what have we learned today? We learned about the Azure Virtual Network and the components that are part of that virtual network, which includes the subnets, the network security groups, the network interfaces, IP addresses, and the VPN gateways. We also learned about the 3 different load balancing techniques, which are Azure load balancers, the application gateways, and the traffic managers. We learned about the differences between the Azure load balancers and the application gateways, and when to use which kind of load balancing technique. All the training materials can be downloaded from the link given on the left bottom corner of which you can see as Azure training. And I hope you enjoyed this session with me. Keep assuring.